This is Lecture 3, Introduction to Game Theory for Political Science, 4327, Introduction to International Relations. Game theory allows us to estimate how actors are likely to interact strategically in international and domestic politics. There are two kinds of games. The first is cooperative and the second is non-cooperative. We focus on non-cooperative games in international relations because they mirror interactions among countries. The prisoner's dilemma illustrates interactions in which actors move simultaneously or the sequence of play is unknown. The sequence of play in non-cooperative games is highlighted in extensive form games. We solve these games by examining in reverse the best replies to the other player's expected moves, and at the step in the decision-making process, backwards induction, and by identifying the sub-game perfect Nash equilibrium. Spatial models and expected utility calculations are static and do not consider that actors engage in strategic behavior. Game theory is a form of reasoning designed to sort out strategic interactions. Strategy involves figuring out what an opponent is going to do and picking the best response to that action. Cooperative game theory assumes that promises be made between actors are binding and will be kept. Non-cooperative game theory assumes promises are not binding, actors can cooperate, but only when cooperation is in their best interest. The credibility of their commitments depends on those commitments being of sufficient value that it is in one's best interest to honor. The Prisoner's Dilemma is a classic two-player non-cooperative game. Two prisoners, Chris and Pat, must decide whether to cooperate with each other and stay silent or confess to the police, noted as defecting, incriminating the associate in exchange for a lighter sentence. Their payoffs under the Prisoner's Dilemma is temptation, is preferred to reward, is preferred to punishment, is preferred to suckers, or T is greater than R is greater than P is greater than S. The sequence of play is unknown. The game can be presented in this matrix form, table 4.1 in your textbook. Each prisoner's strategies, cooperation, or defection are represented in rows and columns, respectively. The respective payoffs are represented in the cells of the 2x2 matrix. Row player's payoff comes before the comma, and column player's payoff comes after the comma. A player's strategy is its complete plan of action, reflecting what it will do contingent on the other player's possible moves. The game is solved by finding a Nash equilibrium, the outcome from which no player has a unilateral incentive to switch from. Here the Nash equilibrium is defect-defect, leading to a P, P outcome. Defection is each player's dominant strategy. Afraid of the sucker's payoff, neither prisoner has a unilateral incentive to switch to cooperation regardless of what the other does. The dilemma that is the pursuit of rational self-interest leads the players to their second worst outcome. The PP outcome is said to be Pareto inferior. Both prisoners could have been better off by coordinating choices, moving to R, R. R, would be Pareto improving because neither player is made worse off and at least one is better off. Non-cooperative games well describe international interactions under anarchy. Unlike the Prisoner's Dilemma, many games have multiple equilibria. There are different ways to play the game consistent with the idea of a Nash equilibrium. Battle of the Sexes is a useful example. A husband and wife want to go out together, but one prefers going to the movies and the other prefers the opera. It resembles two leaders' choice or decision about reducing greenhouse gas emissions. They prefer coordination, but Chris favors emission reduction, green, while Pat does not green. And if you check table 4.2, it has the payoffs. Okay. The game has two pure strategy equilibria, green, not green, and not green, green. The game has a third Nash equilibrium in mixed strategies. The idea of mixed strategies involves choosing actions probabilistically to neutralize the opponent's distributional advantage in selecting one action over the other. Chris knows Pat prefers coordination on not green. Pat gets a payoff of 4. Chris's goal is to make Pat indifferent between coordination on not green and coordination on green, where Chris gets a payoff of 4. Chris does this by choosing a probability P for green and a probability 1 minus P for not green that equalize Pat's expected utility for the two strategies. Chris estimates for Pat expected utility given green two times P plus 1 minus P multiplied by 0. For Pat expected utility not green, it's P times 0 plus 1 minus P times 4. For Pat, given that Chris chooses green with probability P, 2P equals 4 minus 4P, and whenever we solve that out, it comes to P equals 2/3. Pat will do the same, choosing green with probability Q, so that Chris is indifferent between green and not green, which, doing the same calculations, is Q equals 1/3, and 1 minus Q equals 2/3 alternatives. Green happens 2 out of 9 of the times. Not green obtains 2 out of 9 times, and 5 out of 9 of the time they fail to coordinate. In essence, they traded some coordination opportunities to minimize distributional tension. Normal form games assume the sequence of play is unknown or that the players move simultaneously. Extensive form games emphasize the sequence of play. Choice nodes are points where a player must choose some action. Choice nodes are linked to other choice nodes by branches. A terminal node is where the game ends. Suppose the United States and North Korea are playing a game of chicken. Their alternatives are between swerving, compromise, and going straight. Sanctions for the U.S., attack for North Korea. As you can see in figure 4.2, it is laid out for you in an extensive form. Okay. Subgame perfect Nash equilibrium redefine the idea of a Nash equilibrium by eliminating threats and commitments that are not credible. All subgame perfect Nash equilibria are subperfect Nash equilibria are Nash equilibria, but not all Nash equilibria are subgame perfect.